This is a presentation that I went through last night because I haven't given it in a while. And so we'll work through the entertainment together, so to speak, tonight. Let's see if I know how your laptop works here. So my background, I was a private pilot for years and years and years, and I learned a little bit of weather during ground school. And then I went down to Yuma and I was a flight director on the tethered aerostat system. And probably the biggest part of my job was learning to read the weather, not so much in 7 days in advance, but what's it going to be in an hour? Because it takes me an hour to get that bird back down and on the tower. So we'd fly it at 10,000 feet. We could recover it typically 250 feet per minute. So you're looking at 40 minutes just to get it back on the tower and then get it secured and everybody back in the buildings. You're looking better part. So that's where I really kind of started picking up various tools I could use to do weather and weather briefings. And, you know, there were several times, if I jump back here to that picture, I would stand literally on top of that building when we were recovering the aerostat. And several times I did that with lightning within about a mile, which is really frightening, just for the record. So it was pretty exciting times. So a little bit about the typical weather in Arizona. Of course, we get the summer monsoon storms, and the Weather Service changed the monsoon season to June 15th and ending on the 30th back in 2008. It used to be they'd look for dew points, I think over 65, as I recall, for so many days in a row, and then they declare the monsoon to be started. But it's easier now, we just pretend. During the monsoon, typically in the summertime like that, we get cloud bases that'll form anywhere from 8 to 10,000 feet above the ground or sea level, depending where you're at. And typically those clouds would form where there was lifted air. Well, you say, what's lifted air? Well, you get a wind over the surface, it hits a hill or a mountain, and it goes up and it carries that warm, moist air up into higher elevations. And when it gets to the dew point, it forms a cloud. So it depends again where you're at in the desert and how much moisture there is. Some areas of Arizona become their own weather makers. The rim, for example, is a good one. And then in the summertime, a really good storm will have cloud tops typically in the 40 to 50,000, but you can see them anywhere from 25 to 30 to 40,000, depending on the storm. Taller the storms are, generally speaking, the worse the weather is going to be underneath them. And then Virga is really common. And we see that a lot in the desert out here because, again, the bottom of the cloud is at 10,000 feet. It starts raining up there at 10,000 feet, but it's got a long ways to fall. The air is warm and it evaporates, and it just evaporates before it hits the ground. I call it summer popcorn, and that was kind of from being down there in the aerostat site because it would just pop all day long. And again, when you're out there with an aerostat that weighs 12,500 pounds and you got people's lives in your hands, you tend to pay attention to it. And typically what you get would be an isolated storm or an isolated cell that would start popping anywhere from 10 to 11 in the morning. And again, lift is generally needed to get it to pop up and actually form the cloud. But once that happens, the sun starts cooking it, and it'll tend to grow and get bigger and bigger. And then oftentimes what will happen is those will rain out, they'll form, they'll build, they'll rain, and then they'll start over. And if the moisture didn't move away because of surface winds, they'll form in the same place over and over, and you'll get storms every couple hours, basically. On the other hand, if they get big enough, oftentimes they'll draw their neighbors in and they form one big cloud, and they get organized into larger and larger storms. And when you're out there, you know, in the desert and you're watching the weather above you, you want to watch, are these clouds starting to coalesce, you know, around each other? Those are things you want to pay attention to because it can get pretty ugly pretty quickly. And like I said, the steering winds would be typically surface winds. You know, the clouds will typically follow those wherever the moisture is, and drift around. So You'll either get it because there's surface winds that are pushing it, or that the moisture is, drifting with the terrain and popping up a new storm wherever the moisture is getting up to the dew point. Now, winter storms a little bit different. We've been getting a whole lot of these recently, and typically much lower cloud bases, 3,000 to 5,000 feet. The cloud tops run 10 to 15,000 feet, and you don't get that percolation typically that you get in the big summer storms. So you don't get as much lightning, and you don't get as much wind out of them as well. And they tend to linger longer, and they can dump a whole lot of water. Jumping back a little bit to the summer storms, one of the things that you really have to watch out for is that when you get a summer storm and it grows, let's say, to 40, 50,000 feet in overall elevation, that rain starts falling from the top of that. It probably is dropping as hail, and it starts to gather a whole lot of air with it as it's falling. And it will continue to fall until it gets down to the ground. Well, it basically will drag a lot of air with it. Now, when it gets down to the ground, by that time, usually the hail's melted and turned into rain. The rain hits the ground, and it either splashes or bounces, and the air just keeps going. It hits the ground, and it'll go out radially, and that's what causes the microbursts out here. And they can be anywhere from 40, 50 miles an hour all the way up to 100 plus miles an hour. And you have to really watch out. I've seen gust fronts come all the way from Tucson and affect Fountain Hills in 90 minutes. So they can really travel a long distance over the desert. There's a lot of internet sites that have come and gone over the years. When I first did this presentation, I used Weather Underground almost exclusively, and they keep improving their service to the point where they've talked me out of using it. And I've actually gone over to doing a lot more with the U.S. Weather Service, because they were putting a lot of their digital products up, and it makes things a lot easier to look at and to figure out what's going on. And I'll show you some of that when we get kind of toward the end of the presentation. The things that I look for the most are places that have good Nextrad products, and we'll talk about what Nextrad is in a moment. But basically, I'm looking for things that'll show me not only what is the rain level or the reflectivity down low in the cloud, as well as what it is up high in the cloud. So composite is a sliver of that cloud, and the base reflectivity would be a very low angle of radar beam on it. I also like to look at radial velocity, which is just a way the radar can measure winds, and the echotops, and I've talked a little bit about the digital forecast. I'll show you more about that in a bit. So what's Nextrad? Nextrad is basically a series of radar stations that are located all over the country, and they're in these big domes. The domes, I think, are about 28 feet in diameter, and the dish nearly fills the whole thing up. And they basically run all the time. They run in one of two modes. We'll talk about that a little bit more. They run between 2.7 and 3 gigahertz. They throw out 3/4 of a megawatt, which is a whole lot of power. And the beams are pretty narrow, 1 mile at about 50 miles away from the station. So they're pretty well suited to storing air the storms are, and slicing them up so you get a good idea where the storm's moving to. So in clear air mode, which we get a lot of out here until it turns into the monsoon season, you basically have 7 slices, and it shows them there in the different colors. It takes 10 minutes to build a volume scan up, and that product will wait until the whole volume is built and then dump it as one piece on the web. So you get updates about every 10 minutes when you're in clear air mode. It takes about 86 seconds to do a rotation, and as it says there, 2 slices are repeated twice, and then it's roughly a 10-minute time to update it. It's also sensitive to smoke and dust. I'm gonna step up here and get a drink here because my voice is trying to go away. So when there are forest fires, you can actually see the smoke trails in the Nextrad sites. No, it moves. Now in the preset mode, they do more sweeps, and they're looking to get the tops of the clouds in the preset. So that's why you see the big step up to pointing almost straight up to get it. They update it every 6 minutes, and the sensitivity is reduced a little bit because the rain tends to reflect better. They don't need it. Now these pictures are off of Weather Underground back in the day, and it looks different now, but products are very similar. So I'll show you again when we get to the end of this. I'll pull some of the products up, but basically, looking at the various products, the ones in the middle at the top is radial velocity. The red colors are winds moving away from the station. The cool colors are the ones moving toward the station. In the Midwest, they use that very extensively to look for tornadoes. The one on the left is composite reflectivity, which is basically showing you a vertical slice through the cloud and the total reflectivity of all of the moisture in that cloud. The one on the right is base reflectivity, and it's showing just the bottom of the cloud. So in base reflectivity, if you see reflections there, you typically are having rain. In composite reflectivity, typically you don't, because you're looking at the whole volume of it. Down in the bottom left is a calculated rainfall amount. So the reds are various different amounts of rain. The green is light rain, the red is the heavier rains. And then on the right-hand side, it's showing storm tracks, and the system will actually say, oh, this looks like it's a storm cell. I'm going to track it. And the segments in that white line are about 20 minutes each. And when you watch those things, they just scatter all over. Every different volume that you look at is a little bit different. So you get some idea where it's going and when it's going to get there, but in reality, they bounce around an awful lot, especially in Arizona. Now there's new products that are up there on the Weather Service site, and I'm not going to go through all of these, but if you play it back off the web, you can read through it, and I'll show you how to find them here in a moment. But basically, this defines what's available to you currently, and so you get base reflectivity, you get base velocity. Again, that would give you the winds closer to the surface. The dual precipitation, dual polarity precipitation type does a calculation on the amount of moisture in the cloud. The one below it is the differential reflectometry, and that they apparently can pull horizontal versus vertical out of those, which is interesting on which way the the cell is. Is it building vertically or is it building horizontally? High resolution echo tops, just showing you how big the storm is getting. When our precipitation accumulation is just exactly what it says. Storm relative motion generates those arrows that we looked at earlier. Storm total precipitation, and it's up to the Weather Service to say, okay, this storm has ended and the next one started. So it's somewhat arbitrary on what that actually gives you. Composite reflectivity really gives you the energy in the storm very clearly. And it also will show you, I'll show you some slides going forward, outflows and what they, there's some dangers associated with outflows that we'll talk about in a moment as well. And then VIL is a vertical integrated liquid. And basically VIL tells you how much moisture is in that cloud in a column that's a meter wide. And the Weather Service uses that for a lot of their calculations. So digital storm total is the precipitation. And again, we've got another base velocity here. So you can see where you can go to the radar FAQ and available products, and that's where you'll find all these definitions. So again, composite reflectivity shows the highest reflective amount in a vertical slice in the cloud. And it really gives you a good idea where the energy is in a cloud. It also shows outflow boundaries very clearly. And I've got an animated image that we'll see in a minute that will show you that. Green in the composite reflectivity typically is not rain, but the yellows typically would be. And this is a image that I got from the Weather Service. It was in the Midwest, but it really, you see the blue lines of the red that I'm pointing with there, basically is showing the outflow from those storms. And it's literally just pushing air away from that cell just about 360 degrees. And the reason that's significant is if it finds a mountain or a hill and it pushes that more warm, moist air up, it's going to form a cell there. So it's something to look for. When you see it in a moving radar, image when it's animated, you can actually see them come out of a strong cell. And we'll see that in a minute in the animation. So where the red circle is, if you kind of watch in there, you see that green line of it's an arc that's moving to the southwest. That's the outflow from that one cell, and it's found some hills, and it's basically spawning off into a pretty significant storm, and it's doing it in a matter of about half an hour. So you can get a pretty drastic change in your weather in just a half hour. Those are things you want to watch for. And you see, I did that image in 2010 in the afternoon, and I was really amazed at how powerful that storm was coming in from the east. One of the interesting things, and I don't know that they're doing it in the current products because I haven't had a chance to really look at them recently and play with it, but the pink triangles are showing that there may be a tornado signature there where they're seeing rotation in the wind velocities. And so those will pop up automatically and show that there might be something entertaining there. You don't see here, they do happen, but typically, they'll pop up and then go away. This is real rain. Even green on it is extreme. And of course, the red is a lot more rain. And so this was a pretty powerful storm that happened way back when. It's interesting, the low angle is still at 2,300 feet, and it's 50 miles away from the station. So you're really seeing down almost right on the deck with it. Again, this is radial velocity, and the red colors typically are moving away from the station. The bluer colors are moving toward the station, and that the pinkish color that's out, about halfway out through the sweep is where it just can't make any sense of what it's getting. It's not getting enough Doppler in the direction that it believes the winds. The other thing is that if the winds are tangential to the beam, you typically won't see them and you'll get that pink as well. So it's really good when the winds are, coming or going directly at the station, but if out at, some distance away from the station, they're tangential, you just won't see much. And again, echo tops are important because it gives you an idea of how strong the storm is. Now this one, they were getting up to 20,000 feet, so it wasn't a really big storm. But when you see them up in the 40 to 50,000 foot, there's going to be a significant amount of rain and a significant amount of output that's coming from that storm. So NextRad
I'll text him. We cannot hear any audio and the presentation content is no longer displayed. We see content, but no audio yet. Again, no audio. James, maybe you could try unmuting and see if your mic's working. Still muted. No audio from the presentation, but we do have the content digital forecast tools up.
Now,
Are we making it?
There we go. We
do
have.
we have audio?
There we go. We got it.
Okay. Thanks.
See if I cannot blow up the computer here. So with the wind barbs are kind of unique in that they show you not only the direction, but the velocity. And you can see here that, you know, for example, it's showing you 20 miles an hour right there. But back in the old days, they wouldn't typically tell you what the speed was. They would just give it to you with the length of the arm. So notice that you got a short one here and a long one. That's about 15. Okay, 2 long ones would give you 10. If you were to get up, you know, 4 long ones, you'd have 40. And then the arrow end of it, or the fletch end of it, is the direction the winds are coming from. So in this example, the winds are generally coming in from the southwest. Although up here you can see that it's coming almost due north at about 10 right there. So it gives you not only the direction, it gives you the speed of the wind, and then the blue line above it will give you the gust of the wind. So if you're, you know, steady state in about 20, but you can see here they're expecting at about noon it's going to gust somewhere in the 30s. So it does give you a lot of good information in that part of the digital forecast. Now, in the rain section of it's kind of unique in that every 6 hours, and I've kind of put the red bars up here, you notice it says that there's about 53 hundredths of an inch here. Now, I grabbed this chart out of the Midwest last night, and they're going to get a lot of rain where I grabbed it from. So, and a lot of thunder, and it tells you how, you know, likely you are to have lightning with it. It could be, you know, slight chance, likely, occasional, or when it gets all the way up to the top, it's pretty much a guaranteed. From a weather side of it for special events and that sort of thing, sometimes it can be helpful to be looking at this stuff. And with it being on the internet the way it is, you can get it in just nearly, you know, real time if you're looking at the radar. And I'm going to jump ahead here for a moment and on this and kind of show you how this guy works. I hope. Yep. Could be. It's a government, you know. They're here to help us. Hey, it figured out that it's weather service. So when you first come to the weather, .gov, you're going to be, given a map of the United States. And in our case, if we wanted to drill down, and look what the weather it's going to be, I usually click somewhere around Phoenix. And I apologize, our service is a little slow here, so it may take a little bit to populate. And then what it basically does is bring up a kind of a forecast and a warning page, which you'll see here in a moment when it loads. And it tells you what all the warnings are they're going to paint. We're going to see that. I think we still have some warnings up for flooding, so, but not much. The bright green on the map here. And if you scroll on down, if we click on the map, and I'll just click in the vicinity of Phoenix, what that's going to do is bring up a forecast page directly for wherever I clicked. And you can kind of see that I clicked up North Phoenix way. So let's come down here to more or less where we are right now, which I'll click it right about there in Tempe. And what that's going to do is bring up a forecast for, 3 miles northwest of Tempe, Arizona. What's that? Looking at it, it looks like it's probably about 3 or 4 mile box, just, kind of eyeballing it. And if you, put your cursor in here, you can, literally zoom up to whatever level you want. And then below this, you're going to see that there's an hourly weather forecast. And if you click on this, what it'll do is it'll give you a page, and you can actually unclick some of this stuff if you don't want to look at it. It's up to you. Okay, and it will show you again the winds. Up above this is temperature and the dew point. By the way, if they cross, you're generally going to get fog or cloud. And then down below it, it gives you relative humidity, the precipitation potential, and the sky cover. So if you're out doing an event or something like that, knowing how much of the sky is going to be covered may be helpful for whether you need to bring a lot of sunscreen or not. So it gives you a lot of detail. Also, if there's any, rain or lightning in the area, it'll tell you that here. If there's snow or freezing rain, sleet, depending where you're at, all that sort of stuff will populate as well. Now, if I back up a click here, this is all actually from the model data. So the Forest Service, their machine is kicking out models every 6 hours, and it goes and looks at what the model is going to be and pulls that out. Okay, so it's model information. When I worked at the aerostat site, I had to go find all the models and look at them myself. This is just so much easier. I'm lazy now, but so I'm going to kind of scroll out on this map, and the cool part is you can literally go across the country. And if I were
Hey,
to
Jim.
click somewhere in this area,
Hey,
I
Jim,
think
it's
there's a
Travis. I have a question.
fair amount of precipitation in there. No, go ahead, Clark.
Hey, Jim, it's Travis. I have a question.
Okay, Travis, go ahead.
Can you go up to Montana so I could see what's going on? I have family up there, and possibly.
No, maybe at the end of it. How's that?
Yeah, in Eager, I have family up there, so I'm kind of concerned.
You could go on your own computer. Let's see the presentation, please.
Okay.
So with this, okay, we can, click, and I've somewhat randomly picked a spot that I looked at earlier and knew was going to have some weather. And you can kind of see up here that we're going to get a lot of rain. And with that's going to come a whole lot of thunder as well. And I'm sitting too far back to be able to read it, but you know, these numbers between the black lines here will tell you how much rain in that 6-hour window is going to fall. And you know, those can be fairly good size depending on where you're at. The other thing that's significant up here, if we look at the graph, they're probably going to get some fog, especially in evening hours up here, because the temperature and the dew point are virtually identical. So again, you can get a lot of detail for this. And this is, you know, essentially for right now, right? But if I wanted to look at this, you know, let's say several days in the future, you can select it up to about a week out, and you can look at it and go, oh, look, the rain went away finally. All right, good. Life's going to get better in a few days. But, you know, keep in mind, the further away from the date that the model was generated, the error bars go up significantly with that. So it is kind of a useful tool and one that I really do like using. I'm going to back up a couple pages here. Still ways away. And then the other thing that you can look at in here is you can look for the radar information, and I think I usually go to it from up here, so I have to kind of peek at it, figure out where they've hidden it at the moment. But I've gotten to the point where I rely on the digital forecast so much that I very rarely even go look at the radar. So let's see if this will get us in the neighborhood. Yep, that will. So this will tell you what your station is that you're looking at. We're, you know, looking at the one outside of Phoenix. It's down in basically Chandler Gateway. And I believe, oh, that's what I'm looking for, that link right there. Say that again. 124. Okay, and this is where you can select the various products. So we'll see if there's some wind out there that we can actually see. So again, winds, the red is going away from the station, green's coming at the station. And so you can pick whatever product you want up here and look at it. There's really nothing above us right now, so you're not going to see a great deal here, but this is where you would go to select the products that you want to look at. And you can look at it at the station level if you want, or you can look at it, I believe they'll give you a link in here for the national as well. But I guess on this one, because we're zoomed in on it already, that's what it's going to show us. But it's worth poking around and seeing what you can get to with this part of it. And you know, this, by the way, shows you at this point all the various NEXRAD stations around the country and their general coverage area, which is mostly around population areas or fairly good size airports. So, all right, let me jump away from this for a minute and we'll see if we can go back up here, because I jumped out of the presentation. So generally, if you're, you know, assigned to kind of watch the weather, what you're looking for is changes. And if you're out on an event, that might be wind, it might be rain, lightning always. And just as a side note, this slide is dated, but typically horizontal lightning will travel about 30 miles. So you can get struck from a long ways away and not realize it's coming. If you are seeing lightning within 5 miles, 5 seconds to the mile from the time you see the flash to hear the thunder, you definitely want to report that. And you should probably be seeking shelter, especially if the storm's coming towards you. And then the other thing is, if you see or you experience a gust front that comes through, probably coming from a storm, you know, distant to you, basically, like I showed you in that one animation, you can get a cell that'll spawn, especially if, that one that we were looking at was spawned off the Santan Mountains. So if you got something, even if it only sticks up 1,000 feet, it's enough to pop it up high enough to get a cloud to form and lightning to come out. And I had a situation, this was back in probably 2006 down in Yuma. We had a storm up here in the valley that ended up with a dust storm out by Palo Verde. It actually ended up like a 20-car pileup on I-10. And the gust front from that storm cell traveled all the way across the desert. And I watched it, I could see it on the radar. And when it got to just north of the aerostat site, it popped up over the mountain that was right there. And it formed a storm just like that. And, I saw it coming, but I didn't realize how quickly it was going to form. I got an education that night. And, when you get a balloon up there that weighs 12,000 pounds, it's affected by wind, it was a pretty exciting recovery that night. When I left the aerostat site in 2008, I had the record for rolls on the aerostat. It was a quite violent evening as we drug it back down. So they can form quickly, and you really do have to pay attention where they're at. And that's true even if you're not on an event, you're just out, you decide you're going to go four-wheeling in the desert. Keep an eye on the sky. When you start seeing the bottoms of the bases of the clouds getting noticeably darker, and you can look at them, and a minute later you look and it's like, wow, it got a lot darker. It's time to be heading off the trail. So pay attention to the sky. So one of the things, if you're doing an event, it'd be really helpful if you knew where the event was on the radar map. And in the old days, on those first radar charts that I showed you, it was sometimes hard to pick out points on those maps that would correlate to where the event was. But now that they're putting these maps on Google Maps, you can zoom in right to where the event is. It's real easy to do. You want to look at the extended time of the event, see if when people are going to be getting there, because that may affect their ability to get to the event or to get home after the event. And then what are the weather dangers? Are people, like for the Crown King coming up this weekend, well, if they were get a lot of rain or even a little rain up there, flash flooding could be real because the ground's pretty damn saturated now. So you'd want to pay attention to those kind of dangers so that you know what you need to watch for. So and you definitely want to work with the event coordinators if you're doing an event to understand what's going on in the area, and when do they want more information. If you're the guy getting to watch the weather, again, if you're using a Google map that's got radar on it, it makes it real easy for you to see where it is in relation to the event. Use your zoom controls on the map. If you're zoomed right in on top of the event, you may miss the bigger picture that's just outside of it. So zoom out to see the big picture, zoom in to see the event itself. If you have screens with the capability, use both screens. Get the radar up maybe on two different screens, looking at composite reflectivity on one maybe, and base reflectivity on the other one as an example, or the wind velocities would be another one to pick. And then lastly, make sure your communications are clear. Work out in advance what they want to know about so that you can communicate it, concisely, and let people know what they need to know. And don't guess. Again, there's a lot of different tools. Weather Underground has a really good tool as well. I've gotten to the point where I use weather.gov almost exclusively, but you may find that you like other ones, so go looking at them. And if you Google NEXRAD basics, you'll find that there's a lot of tutorial sites out there that will help you understand what's going on. And then, practice the next time there's a storm in the neighborhood, follow it and see what it's doing, see if you can predict where it's going, and the storm reports that you get back from the various media sites. So these are some that I picked up when I was doing the actual presentation, and again, it's probably, there's probably newer and better stuff out there, but this will get you going. Again, I use weather.gov. We did the demo already, so we'll step through it. So any other questions that I can answer tonight?
Hey, Rick, I got one comment. That is, go play with the radar when there isn't weather, so you get used to what's normally there. I can tell you from Skywarn experience, people call and go, there's all this stuff on the radar. How come I'm not getting rain? And the sun's shining. So, you know, you need to get used to what is normally there, the reflections and
Yeah,
all the garbage.
exactly.
So
Exactly.
don't wait till the storm to start playing.
Yeah. You know, when I was down at the Aerostat site, we use a Yuma site all the time. And we got to the point where we could tell where the rain was because we see the ground clutter would suddenly start popping up in different areas. And we knew that that mountain was getting rain. It would start to show up. So yeah, it makes, you know, a lot of help. And then at the Aerostat site, we had a Doppler radar on site as well. And there was an ugly storm down there in the desert, and the Nexrad guys were in the middle of a maintenance cycle. They couldn't see it. And so we were sending them, I was literally using my smartphone to take a picture of our screen and email it up to Steve. At the time, Steve Sipple, you remember him, I'm sure. So yeah, I mean, there's a lot of different ways you can get there, but you know, the one thing I'll stress again is be careful with lightning because it can reach out and touch you from a long ways away. So, any other questions?
Thank you. Very, very interesting presentation. Really appreciate it.
Thank you.
Thanks.
Thank you, Rick.
We can take a quick peek here back on it. If I can find my link.
The white.
Hey, Rick, with the winds, the ends with the bar point out where it's coming from,
Yes,
not where it's going.
that's correct. So the arrow, if you were shooting an arrow, the fletch is at the back of it, you know, from where the arrow is coming from, and the tip going the other way. So Travis, where are we looking at in Montana?